Hello, welcome back. The title of this lesson is called Simplifying Expressions Part 1. So here is where we start to put it all together. We've really been working on really important skills, kind of individual little skills, and here we have to really start building our house, putting it together. In these lessons, we're going to write down an expression and we have to simplify it. We have to put it into a simpler form, in other words. And in order to do that, we have to use the distributive property, which we've already learned. We also have to use the idea of combining like terms, which we've already learned. And we also have to use the idea of multiplying. We multiply a number times a term that has an exponent. What do we do? We're going to mix all those together to do all of these problems. Now, let's crawl before we walk, and let me give you something that's quite easy, and then we'll go into the actual algebraic examples. 2 parentheses 3 plus 1. Now again, when you see a number right outside of a parentheses and there's no operation here, this means multiplication. There's an invisible multiply there. Now, how would you do this? From order of operations, you would do the inside of the parentheses first. 3 plus 1 is 4, right? And since we've done the inside here, we can drop the parentheses and it's going to be multiplied by 2. And then we can finally do the 2 times 4 is 8. So we know that this becomes a 4, and then 4 times 2 is 8. Now, what would we do if we wanted to solve it a different way, by distribution? Remember, the 2 is on the outside. It can be distributed in and multiplied in times each interior term, because the multiplication is happening times the whole thing. We can kind of go in there and bomb everything on the inside. So the 2 times the 3, we just write it as 2 times 3. And then we have a plus sign, which comes from here, and then the 2 times the 1, right? So what do we get here? The 2 times the 3 is the 6, and the 2 times the 1 is the 2. We have to do multiplication before addition, and then finally 6 plus 2 is 8, and we get exactly the same answer no matter what we do. And that's kind of the first lesson here, is that often in algebra or in math, there's more than one way to get to the answer. Here in the first few problems, there probably won't be too many alternative paths, but about halfway through this lesson, there will be choices. And my solution might look different than yours, but as long as you meet me back at the answer with the same answer, with valid steps, your solution is perfectly fine too, because there's many times more than one way to do it. So here was our first little problem. No variables, just numbers. I wanted to remind you of what the distributive property is. Multiply times each term on the inside, join it with the sign of what you see. Now let's take this exact problem and let's rewrite it, but let's make it a little bit different. The 2 is still on the outside, the parentheses is still here, but the 3, let's change it to a 3x. The plus sign is here and the 1 is here. Now this looks totally different. When students see this for the first time, the X just turns the brain off a lot. And they're like, that's different, I don't understand, okay? But we have all of the tools, we've built them, right? We said that we can first try order of operations. We can try to do what's on the inside like we did here. But notice that these are not like terms. This is an X term, and this term is a number. It has no variable. So we cannot combine them. Here we were able to add them and then kind of get an answer. But here we just can't do it because these are not like terms. If that is not familiar to you, then go back to the last lesson on combining like terms, and we've gone over it at great length, okay? So what can we do to simplify this? Well, we recognize that this is multiplication going on, so we can distribute in to the inside terms, just like this, just like we did before. So what do we do here? Now that we have 2 times 3x, we can just write that as 2 times 3x, like this. And then the plus sign comes here, and then the 2 gets multiplied times the 1. Right? And just like before, we have to do multiplication first, before this addition, right? From order of operations. So what is 2 times 3x? Remember, this is the skill we learned a couple lessons ago. We have a number multiplied times a number times a variable. What do? This is like 3 horses. The x is horses, 3 horses, and then we choose to double it by multiplying by 2. So if I start with 3 horses and I double it by multiplying by 2, I'm going to have 6 horses. But the x has to come down, because if I have 3 horses and I double it, I have to have 6 horses. The letter comes down too. So we multiply the numbers, we carry the letter down. Then this multiplication, 2 times 1 is 2. And so we have an answer of 6x plus 2. And you say, can I simplify this any further? 6x plus 2. But actually, this is an x term. This is a term with no variable. These are unlike terms. We cannot combine them any further. Just like we cannot combine this one any further, we cannot combine this one any further either, because the terms are unlike. So you see, we're actually using like 3 skills here. We have to know when we can combine terms and when we can't. So we're learning using combining like terms. we have to know how to distribute from the outside into the interior terms, and then we have to know what happens when we do multiplications like this. What do we get? And to simplify the answer. So it's like three things that we're doing all at once. But notice that when we had the previous problem with no variables, we just got numbers as the answer. And then notice that when we did it the second time with variables, we had a variable in the answer. What we're saying is that this expression here, 2 parentheses 3x plus 1, is exactly the same thing mathematically as this one. These are the same. It's just like fractions. 4/8, 4 out of 8 slices in a pizza is the same as 1/2 of a pizza. So 4/8 is the same as 1/2. So they're simplified, they look different, but they mean the same thing. This looks a little bit different, but it means the same exact thing. All right? And if you want to prove that to yourself even further, what we're saying is that no matter what value of x you put in here, you get the same thing. So let's choose the easiest value of x that we can think of. What happens if x is equal to 0? 0 is a number. I'm perfectly allowed to put 0 in there. So if I put 0 in here, 6 times 0 is 0, and then I add 2, I just get a 2. But if I put 0 in here, I have a 0 here now, and then this is a 1 on the inside. 1 times 2 is 2. So if I put 0 in, I get an answer of 2. If I put 0 in, I get an answer of 2. So these really are equivalent, because for any value of x, go ahead and put a few of them in there, you will get the same answer on the left and the right-hand side because they are equivalent like this. All right? Now let's take a look at problem number 2. Let's say I have 5 on the outside, 2 times m plus 4 on the inside. Now we try to simplify this, but we can't. They're not like terms. I cannot combine them. So the only real option I have is to distribute from the outside like this into each interior term. So the 5 times the 2m I can write as 5 times 2m, and then join it with a plus sign because it's got a plus sign, and then the 5 times the 4. 5 times 4. The next step is to do this multiplication. The 5 times the 2 becomes the 10, and the m comes along for the ride. It's like if I had 2 monkeys, and then I decided to multiply by 5, I'm going to have 10 monkeys. So it has to be 10m. And then this, 5 times 4, is 20. So it's 10m plus 20, and this is the final answer. I cannot combine this any further because this is a term with m, and this is a term that has no variable, so they're not like terms. I can't add them. So in many cases, you won't be able to get it down into one answer. This is just as far as you can go. And you have to get comfortable with seeing that. In lower level math, like dividing and multiplying and fractions, we just get one answer. And you always want to see one answer. But when we get into this higher level math, the answers that you get, you might have a plus sign there, but you might not be able to go any farther. So don't force it. A lot of times your answers are just strung out and they have different terms, but you can't go any farther into simplifying. What about 3 times 6h plus 8? Right, so I check for the same things as always. Can I combine the inside? I can't. These are not the same terms, but I can distribute from the outside. And so what am I going to get? The 3 times the 6h. Right? The plus sign comes from the plus sign here, and then the 3 times the 8. All right? Again, 3 times 6h. The 3 times 6 I multiply as usual to get 18. The h just comes along for the ride. And then 3 times 8 is 24. This would be like having 6 horses and then deciding to triple the amount of horses I have. I'm going to have 18 horses. The h has to come. So the answer is 18h plus 24. I cannot combine this any further. So you see, we're using the same skills. I taught you distribution. We're doing that the same. I taught you how to multiply terms with variables. We're doing that the same. I taught you how to combine like terms, and now you know you cannot combine these because we know when we're allowed to combine like terms and when we aren't. All right. Finally, let's take a look at the next problem. 7 times z plus 2. First thing you should check, go inside the parentheses. Can I combine this? No, because they're totally different terms, but I can distribute from the outside. 7 times z, I can just write it as 7 times z, and then the plus sign comes from the inside, and then the 7 times the 2. All right, 7 times z, what is that? It's just 7z. I mean, they just get written together. There's nothing else you can do. Plus because the addition comes last. 7 times 2 is 14. We have to do the multiplications first because order of operations says we do. 7z plus 14, that's all I can do. You might want, as bad as in your mind, your mind might be telling you, combine, 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 but you can't do it because this is a z term and this has no variable at all. The only way I could combine them is if this had a z as well. You have to add apples to apples, oranges to oranges. You can't just add things that are different in algebra. All right, let's take a look at the next problem. Here's a 6, parentheses, 4 plus 4d. Now, notice this one's a little bit different, right? In this problem, it was a something times variable plus a number on the inside, variable plus a number on the inside, something times variable plus a number, something times variable plus a number on the inside. Here, it's not. It's reversed. It's not variable plus number, it's number plus variable. Do you think that's going to matter? No, it's not going to matter because we know that we can follow the same rules. We cannot combine these because these are unlike terms. So we can multiply from the outside. The 6 times the 4, we write as 6 times 4. The plus sign comes from the inside plus sign. The 6 times the 4d is 6 times 4d. And then we can do the multiplications first from order of operations before the addition. 6 times 4, 24. And what is 6 times 4z? We multiply the numbers again, 24, but we have a d here. It goes for the ride. If I had 4 dolphins, that's what this is, but I multiply that amount times 6, I'm going to have 24 dolphins. The d has to come. Now, usually in the answer, we don't want to write the number first. Usually we want to write the term with the variable first. So put the 24d plus the 24. Because addition, it doesn't matter the order you do it. This is the same exact thing, 24d plus 24. Now, up until this point, there's really been only one way to solve these problems: distribute in and simplify. Distribute in and simplify, distribute in and simplify. This is the first problem in the sequence where there's going to be multiple paths to get to the answer. And there's no correct path. There's no path that is better. There's just different paths. So let me show you how to do this, and we'll do it a couple of different ways, and I'll prove to you that it's the same. You get the same answer either way. 3 plus 2j plus 7. All right, so here we have choices. Let's do it the first way. On the inside, because I can go into the parentheses first, I can combine like terms inside of here, right? Because if you think about it, let me go over here. I'll start this solution over here. On the inside, I have a 3 and a 7. These are like terms. The 2j is unlike the other. So I can put the 2j first, and then plus the 3, and then plus the 7. All I did is move the 3 kind of in between these two, essentially, is all I did to put the numbers together. Notice I haven't done any distributing yet. I'm looking on the inside. The 2j can be here, and then I can combine these like terms. 3 plus 7 is what? 10. And it has to be plus 10 because it's positive 3 plus 7 more, positive 10. All right, so I have this problem, but this is not fully simplified because I can distribute in. I can distribute in the 4 times the first term and then the 4 times the second term. What is that going to do? It's going to be 4 times 2j times the first term. The plus sign comes, and then the 4 times the 10. All right, but what is 4 times 2j? 4 times 2 is 8, and the j variable comes along for the ride. And then 4 times 10 is 40. And so I'm done because I can't combine these any further. 8j plus 40, these are unlike terms, so I'm done. 8j plus 40. Now that was one path to the answer, but there's another path. Can you think about what it would be? Let me rewrite the problem over here. 3 plus 2j plus 7. Now this has 3 terms on the inside, but all of the other problems had 2 terms on the inside, 2 terms on the inside, 2 terms on the inside. Even here had 2 terms on the inside. So you're very comfortable distributing in from the outside when there's 2 terms on the inside, right? But actually, the distribution property, it doesn't matter how many terms are on the inside. You can still keep bombing all those interior terms. You know, I call it bombing. What I mean is distributing it in and hitting all of those interior terms. So instead of, like we did here, first simplifying and then distributing, let's do it a different way. Let's just distribute into the first term, okay? And then distribute into the second term, and then distribute into the third term. That is the distribution property. It can be applied to anything on the inside of a set of parentheses, no matter how many terms are in there. So let's just go and do it. 4 times 3, just write it as 4 times 3. The plus sign comes from here. 4 times this is 4 times 2j from here. Plus sign comes from here. I have a 4 times a 7. Right? So let's continue. 4 times 3 is 12. 4 times 2 is 8, but I have a j, so it's 8j. And then 4 times 7 is 28. All right? Now I can rearrange the terms or if you'd like, but let's just instead do this. The 8j will come first. And then what is 28 plus 12? Well, if I start with 28 and I go up 12 more, that'll be 38 and then 39, 40. Look at what I have. It's exactly the same answer as before. So you see two paths. The first path is I recognize, okay, inside of here, I have to do order of operations first. I can simplify this first and then distribute in and then simplify. Or I can not simplify first and instead bomb all of the terms on the inside and then do the cleanup later. So either you clean up first and then do distribution and simplify, or you can just distribute in and do all the cleanup later. It's like simplifying fractions. Remember long back with simplifying fractions. You know, you can divide by 2 to simplify the fraction over and over and over again, but if you think about it, that, oh, maybe I can divide by 10 and I can get the answer in one step. But if I divide by 2 over and over again, maybe I'll get exactly to the same answer by a slightly longer path. Now, actually, they're both not really longer. Notice that this one's not really any longer than this one. It's just a different set of steps. So as we go through the rest of the solutions, sometimes I'm going to solve it using one way, and sometimes I'll solve it a different way, but I want you to know that whatever I do is not the only way to do it. That's what I want you to really know. All right, let's take a look at the next problem. What about 2 times 5c minus c plus 11? I have a choice here. If I wanted to, I could distribute the 2 times this, and then the 2 times this, and then the 2 times this. That would be totally fine. In fact, I'll probably do that here in a second. Or, if I wanted to, I could combine these like terms first, and then do the distribution. So let's do it both ways. We're not going to do both ways for every problem, but let's multiply in and get all of these done and see what we get. 2 times 5c, right? 2 times 5c. Then a minus sign from here. You have to carry the sign from the inside. 2 times c. We're just going to write it as 2 times c. Then a plus sign, the 2 times the 11. Right? What do I get? 2 times 5 is 10. C comes along for the ride. 2c is still here. And then what is 2 times 11? 22. So finally, I have like terms. I can do this 10 minus 2 only because the variable c is the same, and the exponent on the variable is a 1 in both cases. So everything's the same. 10 minus 2 then is 8c. So 10c minus 2c, 8c, and then plus 22. Right? So 8c plus 22. So this is the answer, 8c plus 22. We cannot combine these because they're unlike terms. Now, this will be the last time we do it both ways, but let's do this guy both ways. Let's first go and combine the like terms that we have here. So it'll be a 2, and on the inside, 5c minus c, 5 minus, there's an invisible 1 here, 5 minus 1 is 4c. Plus sign comes from here, 11. Now distribute in. What is 2 times 4c? Plus sign comes from here, 2 times 11. Right? Let's multiply. 2 times 4 is 8. C comes along for the ride. 2 times 11, 22. Exactly the same thing. So again, this is the last time I'm going to do multiple paths because, you know, honestly, we'll never get done. But I want you to understand that there's multiple ways to do it in a lot of cases, especially when the problems get longer. Let's take a look at 12 times 7 plus 5y. Now this one actually really doesn't have any multiple ways to do it because we cannot combine anything on the inside. They're unlike terms. So let's distribute. This will be 12 times 7. The plus sign comes from here, and then the 12 times this will be 12 times 5y. So 12 times 7, what is that? 12 times 7, 84. Plus sign goes here. What is 12 times 5? 60 times y, because the y comes along for the ride. Now I'm going to flip the order of this because I want the term with the variable first, usually. It's not super wrong if you don't do that, but this is generally more correct. 60y plus 84. Final answer. All right, let's take a look at the next problem. I think we can squeeze it in right over here. And we only have 2 more of these, by the way. 5 times 4p minus 3 plus 7 plus 2p. All right, we're going to rearrange the inside terms and we're going to combine like terms because we have right here 4p and 2p. That can be combined and the numbers can be combined as well. So it'll be 5. Let's take the 4p here. This 2p will move right next door. The sign of it comes with it, the operation, right? And then we have a minus 3 plus 7, but we know we really don't know how to take a negative number and add it to a positive number. So let's flip the order of this. We'll put a plus 7 first. The minus 3 we'll put at the end because I haven't taught you yet how to take a negative. This is like a negative 3 plus a 7. So let's flip it around, put the 7 here and the negative 3 after it. So now we can combine all the like terms on the inside. 4 plus 2 is 6p. So this is like 4 puppies plus 2 more puppies is 6 puppies, right? And then we have 7 minus 3 is 4. So now we're at a place where we can do distribution, right? We can go and multiply n times each of the terms here. So 5 times 6p, if I can write correctly, will be 5 here times 6p plus sign from here, 5 times 4. Right? What is this? 5 times 6 is 30. P comes along for the ride, as always. And then 5 times 4 is 20. So 30p plus 20, we have the variable term first, so that's what we want, and that's the final answer. All right, here's our very last problem, and we're done with this lesson. Here it is. 8 on the outside. On the inside, 9 minus 2w minus 4 plus 6w. What do we do? Again, we could, if we wanted to, we could just forget about simplifying this. We could just multiply times this, multiply times this, multiply times this, multiply times this. Get all those answers and then simplify the results. I usually choose to simplify the inside first. It's just kind of a personal preference thing. So on the inside, what are we going to have? We have a 9 here, so let's put the number right next door. Take the minus 4, put it right next door. Right? And then we're going to have a minus 2w, right? We would have it right next to the 6. So let's just make it easier on ourselves and put the 6w first, positive 6w first, and the minus 2w next to it. Because I haven't really taught you how to take minus 2 plus 6, so it's just going to be easier to reverse it. Put this here and this here. So 9 minus 4, these are like terms for 5. And then 6 minus 2 is 4. And of course, w's here because it's like 6 whales minus 2 more whales. I have 4 whales. And then finally, we can distribute. Here we have 8 times 5 by multiplying this one. The plus sign comes here, and then the 8 times the 4w. Right? 8 times 5 is 40. And then 8 times 4 is 32. And the w comes along for the ride. So the actual answer is going to be 32w. I like to write the term with the exponent, with the variable first, plus 40 here, plus 40. So the answer, 32w plus 40. So here we have begun the sequence here of simplifying expressions. Crucial and essential material. We actually have, this is part 1, we have a part 2 for simplifying expressions, a part 3 for simplifying expressions, and a part 4 for simplifying expressions. You might guess that since I have not 1, not 2, not 3, but 4 lessons on this topic, it must be important. It really is. It is absolutely foundational to everything that comes later. So I want you to go through these. Make sure you understand everything, can get all of these answers correct. And then follow me on to part 2 and part 3 and part 4 where the problems will get a little more complex, but all of the underlying skills, you already know them. All we need to do now is practice. So solve these, follow me on to the next lesson. We'll continue conquering the topic of simplifying expressions.